Yeah. Yeah, good evening all. So myself, I'm Vijay. I hold like 17 plus years of experience, which includes 8 plus years of experience in Hadoop and Spark environment, right? So as part of today's demo, I'll just going to cover the following topics, like what is big data? Yes. Why Hadoop? So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not, right?
Yes, your screen is visible and the audio is clear.
Fine, thank you. So I'll be giving time for your general queries at the end of the session. Just and why Hadoop and drawbacks with the current databases as compared with Hadoop. Drawbacks with current databases. Hadoop advantages. Hadoop ecosystem components. Hadoop job market. Hadoop and Spark, right? Job market. Fine. What is big data? The name itself saying that big data, huge volumes of data, right? Huge volumes of data. So today, if we talk like how the data is getting stored, data storage units, right? You should have seen like KBs of data, MBs of data, GBs, or terabytes of data, TBs of data, petabytes, exabytes, zettabytes, yottabytes, sottabytes, so on, right? Yes. So from TB onwards, we say it as big data, huge data, right? So do you think like petabytes of data is it getting generated in the current real world? If so, examples of petabytes of data generation, right? I want the sessions to be interactive, right? So you can unmute and you can just give your responses. Petabytes of data generation, are you able to see that petabytes of data generation? 1 petabyte equal to 1024 TB. 1 petabyte equal to 1024 TBs. That is already 1 TB is a large storage unit, but petabytes or exabytes of data is it getting generated in the current world? If so, examples of it. Examples of petabytes of data generation. Yes. For example, if you take about any banking sector, right, like SBI or HDFC, if you take any bank like SBI, right? So within the city, you see hundreds of branches for a particular bank like SBI. Within the entire state, you see thousands of branches for it. Within the entire country, lakhs of branches for it. Again, within each branch, millions of customers, each customer making multiple transactions per hour, per day, per week, per month, and per year. Each and every transaction need to be stored, right? Huge transactions you are going to see, huge data. Forget about this. Everyone are aware about social media like Facebook, right? Facebook has got users not only within the country, within the entire world, right? Millions and trillions of users for Facebook. In a minute, how many posts and videos are getting circulated? What should be the storage capacity? What is the data generated by Facebook in a minute? Not in GBs or TBs, right? Petabytes of data generation. Not only like Facebook, right? Today, if you talk about any application generating huge data. If I talk about 1 minute transaction, if I talk in a minute, how many Facebook posts, FB posts? What is the data generated by Facebook in a minute? Twitter tweets, what is the data generated by Twitter in a minute? And everyone querying in the Google, right? What is the data generated by Google in a minute? YouTube videos upload, right? Everyone creating your own videos and uploading in the YouTube, right? What should be the storage capacity? YouTube videos upload. and millions and trillions of users using email or Gmail messages, right? So what should be the storage capacity for storing all these messages? Just now we're talking about bank transactions for thousands, for lakhs of branches, millions of customers making multiple transactions. Even for telecom transactions, right? And if you talk about like e-commerce websites, like e-commerce sites like Flipkart or Amazon, right? Generating huge data, right? And an average, they're generating like Google generating more than 800 petabytes per month on an average, right? Means 800 into 1024 TBs data generated at an average in a month, right? So how this data is getting, so we have got some databases for storing this data, right? We have got databases for storing this data. Databases like Oracle, MySQL, DB2, SQL Server, DB2, right? These databases, they are used for OLTP, online transactional processing, for day-to-day operations, right? These databases can handle data up to some extent, but we have got some specialized databases. Right? Like Teradata, Netija, Vertica. So these are used for data warehouse purposes, OLAP, DWH, right? Data warehouse purpose. But these databases or specialized databases, they can handle data up to some extent, but beyond that, they cannot handle the data, right? So for that, as a storage level problems, and not only storing that huge data, processing that huge data, we need to have some proper tools for storing and processing it. So we got a framework like Hadoop, right? Which can store huge data and which can process huge data. But later I discuss what are the services provided by Hadoop. But before that, let me discuss like how this data generation happening. What are the different types of data and sources of data, right? Yes. So if I say like this is the entire data in the current real world, if this is the data in the entire current real world, which got generated from the last 50 years, from 1970 to 2022, right? If you observe this data, this is the entire data you see in the current world. But if you see, observe this is 20%, this is 80%, means 1972 like 2012 or 2002, right? Last 40 years, only 20% of the data. From the last 10 years especially, nearly 80% of the data whatever we see, right, is got generated from the last 10 to 15 years, right? Maximum data, right? But previously, if we talk in 1990s, right? So the storage systems you see, right, we have got floppy disks, just 1.44 MB of size, just not even 2 MB, 1.44 MB for the secondary storage systems. Later you got CD, compact disk, DVDs, right? What are the, see here, 80% of the data has got generated from the last 10 to 15 years as compared from the previous 40 years. Reasons for huge data generation. What are the reasons for the huge data generation, especially from the last 10 years? Because of usage of technology, because usage of internet and usage of smartphones, right? Because of usage of today, everyone using internet, today everyone using smartphones, and the usage of technology, right? Huge data is getting generated, right? The data which got generated, right, mainly it's of three sources. It's mainly of three sources of data. The data which got generated, right, mainly it is from the three sources, right? First, mainly like social data, right? Second, like machine data and transactional data. If you talk like a social data, right? Data which got generated from the social website like Facebook, Twitter, WhatsApp, all this, right? Such kind of data we call it as social data. Machine data means the data which got generated from reading or scanning the barcodes and RFID chips, right? Whenever you go to any shopping mall for the items you purchased, right? A bill is generated, right? Means the data which got generated by reading or scanning that barcodes, RFID chips, such kind of data we call it as machine data. Transactional data, day-to-day operations like a bank. Talk about day-to-day operations like bank transactions, telecom transactions, right? And if I talk that this data whichever got generated, right, from the last 10 years, huge data, mainly occupying three types, right? Going to occupy three types. It's going to take three formats, three types of data. Structured data, you can say like structured data, right? Semi-structured data, and unstructured data. Unstructured data, the biggest challenge today, like most of the data, like 80% of the data, whatever is generated, is mostly in occupying unstructured format. It's going to occupy like unstructured format, right? So storing that unstructured data and processing that unstructured data is the biggest challenge. Means if you take databases, they cannot handle unstructured or semi-structured data. They can handle only structured data. Structured data means which is arranged in the form of rows and columns, which are organized in the form of rows and columns, like Excel sheets, DB tables, and semi-structured, right? Like XML files, JSON files, which are not fully structured, which are not fully unstructured, right? Unstructured, right? Like short messages, articles, images, videos, all comes as unstructured, right? So day by day, as the data is increasing enormously, we need to have proper storage systems. We need to have proper storage systems for storing this huge data and for processing this huge data, right? So as a solution to all these storage level problems, right, we have got a framework called Hadoop. We have got a framework called Hadoop, right, for storing unlimited data, huge data, and for processing that huge data in quick time, right? Hadoop is meant for two things. It is meant for storage. It's meant for processing. Storage and processing, right? Yes. Observe here, we have got the technologies. Any technology, if we take like C or C++ or Java or .NET, anything, they are meant for, these are meant for processing. We take like Oracle, DB2, SQL Server, MySQL, right? They are meant for storage. If you take any technology, it is either meant for storage or it is meant for either processing, either storage or processing. So, but Hadoop is for both storage and processing. Hadoop is meant for both storage and processing. It performs storage and also it performs processing. That too, unlimited data storage, right? And that huge data we need to process in a quick time, so that we're expecting the results in quick time. So the processing should happen in quick time, right? Huge data processing, right? So Hadoop is a technology which is meant for both storing and processing, huge storage and huge data processing. You may get one query, right? If Hadoop able to store and process, what is the necessity of this processing and the storage technologies, right? When it is able to store huge data, it is able to process the huge data. Do you think like when Hadoop in the market, do you think these technologies like storage and processing will be away from the market? You need to understand what Hadoop is able to perform. So Hadoop is for not for OLTP processing, not for online processing, not for day-to-day activities, not for online transactional processing. It is for batch processing. Hadoop is for Batch processing, huge data means like millions and trillions of records. For that you go for Hadoop, not for example, a single transaction. You can go for this databases only, right? For one transaction or two transactions, no need of Hadoop. Hadoop is for millions and trillions of transactions. Hadoop is good for huge data. Hadoop is bad for small data. So here Hadoop able to store the data. Does Hadoop use any database internally? For storing the data, does Hadoop use any database internally? No. I'm saying like the databases has got some drawbacks. So I'll be just briefing you about the databases drawbacks. Despite of this drawbacks, still we don't go with databases for storing the data. So we go with a file system. We go with a file system called as Hadoop distributed file system. Later I'll be briefing you about this Hadoop distributed file system in brief, but Hadoop doesn't use any database. It goes with a file system called as Hadoop distributed file system. And for processing, right, Hadoop goes with a execution model called as MapReduce. It goes with an execution model called as MapReduce. Like, so today, like MapReduce, or currently we are using Spark, right? Spark for processing. MapReduce and Spark mostly used for very high speed processing, right? So Hadoop able to store the data and process the data. Two services given by Hadoop: storage and processing. So if you take the huge data generation, if you take big data as a problem, right? So you can say like Hadoop as the solution, right? If you take like big data as a concept, if you take, you can say like Hadoop as the implementation. Fine. And you may get a query, why databases can't be used? Why databases like Oracle can't be used for storing Hadoop data? What are the drawbacks with the databases? So drawbacks with the current databases as compared with Hadoop only, I'm saying, right? Drawbacks with the databases. So mainly the drawback, one by one I'll be listing out. Mainly like limited storage only. Unlimited data storage is not possible. Limited storage in GBs or in TBs, right? But higher than that, like petabytes or exabytes of data can't be supported by these current databases. And most of the databases, no parallel processing, right? Yes, most of the databases. And that if volume or the size, volume increases, right? The speed decreases, I'm saying. Speed is going to decrease. For example, for this, I'll just, if I take a query, database query, right? Yes, observe this, select the total amount, sum of amount, select the sum of amount from sales one. Yes, select the total amount from sales one. Select total amount from sales two. Total sum of amount from sales one, select sum of amount from sales two, select sum of amount from sales three. Three tables, sum sales one, sales two, and sales three. Total amount from sales one, total amount from sales two, total amount from sales three. Think that sales one has got 10 records. Sales two has got 1 lakh records. Or sales three has got 1 crore records. Which query is going to execute faster among these three? Which query executes faster among these three, right? Total amount of sales one, total amount from sales two, or sales three? Obviously, the first query executes faster compared with the second and third, right? So query to query, as volume increases, speed is decreasing, right? Observe this. Next, like if complexity increases, right? Complexity increases, speed decreases, right? In the case of databases. Okay. I'll take the same query, right? Sum of amount from sales one. Just observe if complexity increasing. If I take a if you take a labor example, right? If volume increases, speed decreases. Even if you take a labor example, if a person carrying 5 kgs, he can run with that, right? If a person carrying 10 kg, if you increase the volume to 10 to 5 to 15 kgs, he can walk with that 15 kgs of that. But if that volume increases to 40 kgs, he cannot even move, right? Means if volume increases, speed decreasing there. Here also in the databases, if the records are increasing, that speed is decreasing. Complexity means, for example, sum of amount from sales one, I got some 1 lakh records. 1 lakh records, right? Select average amount I'm taking. Average amount from sales one. Same table from sales one. Same, it also got 1 lakh records. Select standard deviation of amount. Standard deviation of amount from sales one. Sum of amount from sales one, average amount from sales one, standard deviation of amount from sales one, right? Okay, which query is going to execute faster among these three? Yes, which query executes faster among these three? Total amount from the sales one, or average amount, or standard deviation of amount? See this second query, average amount. It's a two-step process, right? First sum need to be calculated, next average need to be calculated. As compared to the first query, second query takes more time. Standard deviation means lot of internal processing is required, means query to query, as the complexity increasing, speed decreasing, right? Yes. Okay. The major drawback, databases can handle only structured data. Databases can handle only structured data. They cannot handle unstructured or semi-structured kind of data, right? They can handle only structured data. Fine. Observe. One example on this. If you take if you want to take reviews for a particular movie, right? Reviews for a particular movie. The table name itself is reviews, right? Just user or that review. Yeah, user one, right? User one, user two, user three, user four. In this way, 100 users giving the feedback. User one. Yes. User one, right? One is saying that one. User two saying the movie is bad. User three saying movie is good. User four saying that movie is bad, right? So just they are giving the feedback in the form of yes. Yeah, Kailas, I'll just come to your queries right at the end of this. Yes. User one saying one, two, ones and zeros, right? Their feedback is given in zeros and ones. One means good, zero means bad. 1 0 1 0 1 0, right? Zeros and ones. Yeah, just I want that Now, can you count using count aggregation? Can you count the number of ones and zeros and ones? How many people saying the movie is good? How many people saying the movie bad? Can you count using this SQL query that how many ones and how many zeros? Yeah, can anyone say the query? The table name is reviews. The column name, yeah, table name is reviews, right? Select
Select count reviews from reviews where review equals to 1, or
review
when
wise
we want.
count. Yeah, review
Yes,
wise
reviews.
count. Review wise count I want from the table reviews. Single grouping, single aggregation, right?
Yes, yes.
Review wise count I want from reviews table. Group by review means group by review means select output. Observe this output. Review wise count means for review means 1 and 0, right? 1 and 0. 1 0 count. 1 count is 90, 0 count is 10. Count review wise count I got from. You will group all that reviews of 1 and count on that. You will group all that reviews of 0 and count on that, right? You got this is the output. 90 people saying the movie good, 10 people saying the movie bad. But generally the feedback is not given. The reviews are not given in the form of zeros and ones, right? They give in their own text format. The first person saying that movie is good. Second person saying that movie is not good. In this way, their reviews are given in their own text format. Now, can you write an SQL query for this? Can you count the number of goods and not goods? So this kind of data can't be handled by database. So even if you go for keyword count, it gives wrong computation as even not good is having good within it, right? So it gives wrong computation. So these are the drawbacks, right? So as compared with Hadoop only, limited storage, no parallel processing, volume increases, speed, complexity increases, speed decreases, can handle only structured data. So, okay. Now coming to Hadoop advantages, right? Coming to the Hadoop advantages. To know Hadoop advantages, at least like minimum, you need to know about at least the overview of Hadoop architecture, right? So I'll come back to this Hadoop advantages. Just I'll take a minute or two to discuss Hadoop architecture. Like later I discuss in brief about this. Hadoop is not for client server. Hadoop doesn't follow client server architecture. It won't follow request response architecture. It won't follow. Right? Okay. Hadoop follows master slave architecture. It follows master slave architecture. Single master, multiple slave architecture, right? It follows master slave architecture. Observe this diagram once. Master and slave. This is master. These are slaves. S1, S2, S3, so on up to Sn, right? This we call it as slave nodes. Slave nodes. This is like master node. Master node, or in Hadoop terminology, we say like name node. This is slave nodes or data nodes, we say. Why the name data node? Why the name data node? Means in Hadoop, data is stored within the slave, data is processed within the slaves. Master node or name node, or slave node or data node, right? Yes. So in Hadoop, data is stored by the slaves, data is processed by the slaves. For example, in Hadoop, data is stored in the form of files. f1.txt file. Assume here each slave 1 TB of 1 TB, 1 TB, 1 TB, 1 TB, right? Yes. This f1.txt size is 2 TB. This 2 TB cannot fit into slave 1 or slave 2 or slave 3 or slave 4. They have 1 TB. So in Hadoop, the data will be distributed into smaller parts. Data is going to be partitioned into smaller parts. Each part is going to be stored across multiple slave machines, multiple slaves. The data is going to be stored across multiple slaves. Okay. So here data is distributed across multiple slaves. Data is distributed across multiple slaves, and data is stored means 10 lakh records in this, 10 lakh records, 10 lakh records, 10 lakh records, 10 lakh records. Okay. Name node, right? Name node is responsible for that. Yes. Name. So here 10 lakh records, 10 lakh records, it's stored across multiple slaves, right? Multiple slaves. Yes, sir. Chandrasekhar, in MongoDB, you have got a limitation. You can go up to like 500 slaves only, right? Rather than you can go maximum, 5,000. But we have got other data, other NoSQL databases like Cassandra is there, HBase is there, CouchDB is there, Riak is there, Peanut is there, right? We have got many other NoSQL, but there is a limitation for MongoDB. It can go up to 5,000 slaves for storing this. So here data is stored across two things you can observe, two advantages you can observe here. Data is distributed across multiple slaves and processed by multiple slaves parallelly. Your data, huge data object is divided into smaller parts, distributed across multiple slaves, processed parallelly. So very huge speed you can see, very high speed you can see, and unlimited data storage is possible here, right? So horizontally, Hadoop has got the feature horizontally unlimited scalability. Horizontally unlimited number of slaves can be added. Okay, later I discuss those properties, right? But here master node, name node, right? Yes. Observe. So these things you need to understand. So now coming to this Hadoop advantages. I'll discuss this architecture in brief, right? Storage architectural and processing architecture in brief, and their components in brief. So Hadoop advantages. Hadoop advantages. First one, unlimited data storage. Unlimited data storage is possible because there is a feature, because of a feature, right? Horizontally unlimited scalability, right? Yes, horizontally unlimited scalability is possible. Means horizontally unlimited number of slaves. For example, you're running a business with a number of slaves. For example, this is your master, you've got only less slaves, only 10 slaves. Your data is increased, your customers are increased, branches have increased, means your data also increased, right? So you cannot go with the same number of slaves as your customers, and customers increased by 1,000 times, data increased by 100 times, right? You cannot go with the same number of slaves. You will keep on increasing the slaves, right? Yes. Horizontally unlimited scalability, you can keep on adding, right? And second advantage, very high speed processing, right? Yes, Cloudera will be covered, right, Mohammed? Very high speed processing, very high speed processing, right? Yes, because of parallel processing, because of what? Parallel processing. can handle all varieties of data, can handle all varieties of data. All varieties of data means structured, unstructured, and semi-structured kind of data, right? Can handle. And open source, it is an open source, no licensing required, right? Cost cutting, you can say. Open source. So very high speed processing because of parallel processing. I'll give a labor example. MapReduce is designed in such a way for parallel processing. It's a component designed for parallel processing. MapReduce performs parallel processing, right? Yes.
Sir, sir,
Yeah.
I'm not able to understand who is consolidating the data and who is doing the parallel processing. Is Hadoop doing it or MapReduce doing it?
MapReduce. So here internally there is a process like job tracker, task trackers are available. Just observe this. So within this master node, we have got some processes like a job tracker, task tracker 1, task tracker 2, task tracker 3, task tracker means job tracker is going to assign task T1 task to this, T2 task, T3 task, T4 task. Means this job tracker is responsible for the entire job. It divides the job into tasks, executing this 10 lakh records. For example, task 1, task 2, task 3, task 4. Assigning the task to the task trackers. Task trackers are responsible for executing the tasks. Task trackers, these are the processes within this, right? Data nodes available. So these task trackers executes the task, and job tracker is collects the final output, right? Job tracker is assigning the tasks and gets the job tracker is responsible. This I'll be discussing in the later architectural part, right? Storage processing components, storage components, and processing components. What are the work of storage components? How exactly their data is stored and how exactly the data processed? Who is responsible for storing? Who is responsible for processing? How it is stored? Okay. How means internally we got blocks. Data is divided into blocks B1, B2, B3. What is the default size of each block? And how these blocks are stored across the slaves? Those things, right? Fine. So coming back, right? It is very high speed processing because of parallel processing. Because of parallel processing, right? Yes. Observe. I give a labor example. Non-parallel and parallel, right? Non-parallel and parallel. If I take about a non-parallel, right? Yes, and parallel. For example, a one person preparing one item taking 1 minute. The same one person preparing 10 items takes 10 minutes, right? The same one person preparing 100 items taking 100 minutes, right? The same one person preparing 1,000 items takes 1,000 minutes. Okay. But here in the case of parallel processing, right? One item, 1 minute only. 10 items, 1 minute only. 100 items, 1 minute. 1,000 items also 1 minute. Means here 10 persons preparing 10 items take 1 minute. 100 persons preparing 100 items takes 1 minute. Say in the case of here persons, but in our terminology, systems, right? Slaves. Fine. So Hadoop advantages mainly like unlimited data storage and very high speed processing and handling all varieties of data. And if I talk about this very high speed, right? Yes, you can just check this, the speed of Hadoop as compared with other databases, right? Yahoo has conducted a test, right? Set has conducted a test to check the speed of various databases. It has taken a table of 100 TB, consisting of 1024 columns. The task sorting based on 16 columns, sorting based on 16 columns, right? Yes, what is the time taken? Time taken, right? Time taken by various databases, right? First, Oracle. It has taken nearly 3.5 days to process it, right? 3.5 days. MySQL. It has taken nearly 6 days. But we have got specialized databases like Teradata, which can handle TBs of data, right? We have got a Teradata, which can handle TBs of data. It has just taken 4.5 hours. Netija, another specialized database. Netija. It has just taken 3 hours. And finally, like Hadoop, right? Hadoop. It has just taken 3.4 minutes. 3.4 minutes for processing it, right? It has just taken 3.4 minutes. The latest version of Hadoop has just taken 1.2 minutes to process it. This is what the speed of Hadoop as compared with the other things, right? So the Hadoop has got a high speed, huge data storage. Today, if we talk like data, you're getting huge data everywhere. You see like huge data getting generated for storing it and for to process it, right? We are expecting the results. The industry is expecting the results in quick time. So we are going with processing tools like Hadoop, right? Which can process the data in quick time. Okay. So like we have got especially from ETL kinds of projects, right, are getting migrated, right, towards Hadoop environment. Wherever you see huge data getting migrating towards Hadoop environment, and even Spark. Spark is a in-memory computation. In-memory computation means within the memory level storage happening, memory level processing is happening. Very high speed you are going to see in Spark, right? Data storage and processing, everything happens at the RAM level. Let's be in. Yes, right. So just I was briefing you about what is big data, why Hadoop, right? Drawbacks with the current databases, Hadoop advantages, right? Hadoop ecosystems means the demo I'll be taking for today and tomorrow, right? 2 days you can just check. I need to discuss about the various Hadoop ecosystem components, right? And if we talk about this Hadoop job market today, if you can just Google and check the Hadoop and Spark jobs, right? If you see the salary packages for that Hadoop and Spark as compared with other technologies, you see like 1.5 times more than the other technologies, right? So at the same time, they'll be expecting the command in this, right, technology, right? So we'll be discussing everything from that ground level to the advanced level, right? From the scratch to everything. I'll be typing and showing you all these things. We'll be taking some bigger data sets, how we are going to store and how we are going to process it by using many processing technologies, processing tools, like and kind of data warehouse kind of environment within the Hadoop framework, using Hive, how to perform querying, how to create tables and how to perform querying on the data, how to make the data structured and storing the data in the form of tables, Hive tables, and just querying on it, right? So as part of this course, I'll be discussing, right, Hadoop components and also like Spark in brief, in depth, right? So, and before the Spark, I'll be briefing you about like nearly like 2 weeks to 3 weeks. I'll be discussing on Scala, programming language like Scala, right? Yes, just observe this course content, right? Yes. Hadoop and Spark with Scala, right? Yes. So here, what is big data? Why Hadoop, need for Hadoop, sources and types, right? Storage and processing and databases versus Hadoop, advantages of Hadoop, Hadoop ecosystem, HDFS, like the storage system, right? Hadoop distributed file system. Their features, how this name node, data node, blocks, how to configure them, configuring block size and replications, HDFS architecture, name node, data node, job tracker, task tracker, how they are going to be performed, storage architecture, processing architecture in brief, right? Metadata management, storage and processing, replications, configuring custom replications, how to have our own block size, how to our custom replications, fault tolerance model in Hadoop, and various commands of HDFS, right? Hadoop distributed file system, and map reduce architecture, the processing domains, job tracker, and the roles and responsibilities of it, task tracker, its roles and responsibilities, phases of map reduce, mapper phase, reducer phase, input split, right? And what is this driver code, mapper code, reducer code in this? Yes, I'll come back, right? Amit Patel, I'll come back to you. Like, and next scoop, right? SQL plus Hadoop. First two characters of this and last three characters of this forms scoop, right? Means how you are going to get the, how you are going to pull the data towards Hadoop. Means how the you are going to get the data ingestion tools. Means you are going to pull the data from different sources, different OLTPs. Means importing the data from databases to Hadoop. How to import and how to export after processing. I want to export the results back to the database. Importing and exporting of data using a component called scoop. So in this scoop, I'll be discussing in brief, right, of multiple imports. Means multiple, how to perform filtering during import, how to perform merging during import, how to perform grouping, and I want only specific columns, how to get specific rows, and how to perform various like merging vertically, horizontally if I want to match, and working with delimiters in during this import, and similarly for exporting, right? Importing also from database to HDFS, from databases to Hive, databases to NoSQL database, from database to NoSQL. As part of the course, I'll be discussing a NoSQL database also, right? As a Hadoop developer, right, you need to have the knowledge about this framework like Hadoop, one NoSQL database, and even I'll be giving knowledge on streaming, right, like Flume and Kafka. So like exporting data from this, transformations and filterings, groupings, aggregations, incremental loading, incremental import, examples and operations, define how to define scoop jobs, and yarn, yet another resource negotiator, right? In the previous earlier versions of Hadoop, there were some drawbacks, right? Architectural issues. Everything got rectified from Hadoop 2 version onwards. We call it as yarn, yet another resource negotiator. What do you mean by speculative execution, speculative job, speculative task, comparison between the versions, comparison between the previous yarn architecture, it's various components, and also like that. I'll provide you the knowledge on a big Apache pig for processing, and my most concentration will be on the important component Hive. Hive is a component which is mostly used in any project, right? Right, it's a kind of data warehouse kind of environment. In Hadoop framework, we use a language called HQL. It will be similar to SQL. We are going to make the data structured and stored in the form of Hive tables, internal, external tables, partition, non-partition tables. We have got a performance tuning mechanism, improving the query performance using the partitioning, static partitioning, dynamic partitioning, and indexing, bucketing, right? And how to work with unstructured data, XML data, JSON data, URL weblog data, and performing unions, joins, and UDFs, UDTFs, right? Using this, and partition, non-partitioned, and coming to this NoSQL database. And in the Hive, performance tuning mechanism, bucketing, indexing, Hive and Hive HBase integration, right? A NoSQL database. What are the different NoSQL databases? Right, introduction to those, and HBase, one of the NoSQL database, HBase, right? Yes. HBase, total discussion on this HBase, how to perform CRUD operations, Hive and HBase integrations, HBase storage handlers, and HBase data modeling, the entire architecture of that. And coming to this Spark Scala. Apart from this, I said I'll be giving knowledge on streaming data and technologies, Flume and Kafka, right? Scala, first observe this. Spark and Scala, right? First, I'll go with Scala programming, Scala basics, data types, Scala variables, typecasting, Scala expressions, Scala control structures, Scala collections and transformations over these collections, right? Scala is the native language of Spark. Spark by default built by using Scala language, Scala functions. So nearly like more than 2 weeks I'll be discussing a Scala before we go with Spark, right? Spark introduction to this, Spark comparison with any other technologies, right? And RTD computation, data objects, Spark data objects we called as RTD, resilient distributed data sets. We say, what are those? What are the features? How it is getting computed? Steps in it. RTD persistence features, various ways of persisting, memory only, disk only, memory and disk only, right? Spark core computation, fault tolerance model, different ways of computing, creating Spark objects from Scala objects, increasing the number of partition, increasing, that is controlling the parallel processing, aggregations over structured data, reduce by key, group by key, reduce functions, groupings and aggregations, right? Different types of groupings, aggregations, process of group by key, reduce by key, various inbuilt transformations and actions, right? One by one transformation, like one by one count by key, all these transformations one by one in brief, transformations and actions. And also coming to this important like Spark SQL, the data frames concept. So Spark SQL, right? Yes. How to make the data structured, case classes, making the data structured, right? And using this SQL context, data frames, data frame APIs, and working with pure SQL statements, Spark and Hive integration with MySQL integration, working with CSV, JSON, and deployment modes, how to perform, right? In local mode, in clustered mode, standalone. And Spark application, what is stages and tasks, driver and executor, and how to submit Spark jobs, Spark Smurfit, creating jar file using Eclipse ID, using Maven build tool, and using the simple build tool, right? SBT for creating an IntelliJ ID. And I'm going to show you on two IDs, IntelliJ ID and Eclipse ID, and build tools like Maven and SBT, and how to launch the Spark applications, how to submit the Spark jobs, and also knowledge on Spark and Cassandra, right? So this is everything I'll be going to discuss in brief, right? Nearly 60 hours for Spark I'll be spending, like nearly 40 hours on Hadoop, totally 100 hours in brief, in depth I'll be discussing, right? Like 2.5 months I'll be taking, right, for this. For Sparks and Scala, like 1.5 month, and for Hadoop 1 month, total like 2.5 months combinedly, right? Okay, those who, yeah, prerequisites, some of them were asking that prerequisite, right? Everything, before I start with the actual practical part, I'll be briefing you with the basic Linux commands. Just the basic Linux commands knowledge is enough. If it doesn't have knowledge, not a problem. I'll be giving the knowledge on these commands for 1 or 2 days. I'll be discussing all that Linux commands. Yes, and are you able to tell end-to-end pipeline? Yes, at the end I'll be showing that entire the pipeline, right? How this flow is going to happen. Cloudera, yes, it is going to be covered, and MapReduce is for parallel processing. Yes. So here previously the usage of Java was lot, right? But the usage of Java has reduced totally, right? We got like Spark with Scala. Most of the time we'll go with Scala programming, Spark with Scala. In Hive we got HQL language, Hive query language. In Pig we have got Pig Latin language. So previously we used to use a lot Java, but the usage of Java has decreased a lot, right? What will be the prerequisites? Show pass. Okay.
Hello, sir.
SQL queries and programming, will it be for me for continue for this? Yes, SQL basic knowledge required, but still you can go with this. We'll be discussing with many SQL queries, right? Duration of the course like 2.5 months. How will we practice means, yes, no, don't worry about the software. I will be providing the software, all the tools, right? To your Google Drives, right? You can just download it, and how I'll just demonstrate how to work on that software. You can just practice. I'll be so Hadoop can be easily be installed, right, with using VMware. I'll be giving the image to you and just work on this. All the components you can work on it, right? I created my own distribution, right? Yes, within that you can see all the components of Hadoop and Spark. Yes. So like Prasad, right? Will you do Hadoop and Spark? Yes. If you want to go Hadoop and Spark parallelly also, first after 10 days of 10 to 15 days, right? We can go Hadoop and Spark parallelly. After
One
10,
batch is going on, right? Can we join that batch? 5 o'clock Spark batch is going on, right?
yeah, the basics of Spark completed in that. I'm starting Scala from tomorrow. In
We
that,
can join in that batch, right? If you want to. Huh?
yes, you can. Tomorrow I'm starting with Scala, right? You can go ahead with that. Scala programming I'm starting tomorrow, right? Introduction to Spark is there. You can, if you want,
Hadoop, yes, sir. Hadoop parallel when it is.
Hadoop will be at 7 p.m. now. You'll be going with Hadoop 7 p.m. right? And if anybody wants to go with parallelly Scala also at 5 p.m. Scala tomorrow, Scala programming. For the next 2 weeks, I'll be discussing Scala programming, right? So by that Hadoop, the basic part will be discussed, covered, right? Like HDFS, scoop, those things. What all the things first required for Spark and Scala, I'll be discussing first in the Hadoop, right? So if anybody wants to go parallelly, can go parallelly. Tomorrow I'm going with Scala at 5 p.m. There is a batch started recently, 3 to 4 days back. Right. Tomorrow I'm going with Scala programming, right? You can just see the link in that website if you want to join for the scale. Duration of the course, 2.5 to maximum 2.5 to 3 months. How many classes on each topics? Yes, see here, I said nearly 60 hours I'll be spending on Spark and Scala, right? Nearly 40 hours I'll be spending on Hadoop, right? HDFS, MapReduce, Scoop, Hive, and NoSQL database. You need to have the knowledge about NoSQL database. You need to have the knowledge about Hive, right? And of environment, and Scoop important, HDFS file system important, right? And also I'll give knowledge on streaming data and technologies, right? Spark streaming, micro batches, how to create the micro batches, right? Duration of the course will be 1 hour, right? Most of the students will be, they can spare only 1 hour. So duration of the course will be 1 hour daily, but sometimes on these weekends I'll be taking some session with okay, fine.
Hello, sir.
Yes.
Hello, sir. If we
Yeah.
compare big data Hadoop with development, sir, like Java and Angular, so what is the scope for big data, sir? Can you please tell me?
Java, using Java. So previously in 2014, 15, 16, like 13, 14, 15, the usage of Java was huge in this Hadoop, right? At least, but once Spark has come, the usage of MapReduce has decreased a lot. Means totally, if I can say today, like MapReduce has total, but MapReduce. Now we are going with Spark only maximum, or Hive. We are going with Hive, or going with Spark maximum.
Okay, sir. But
Java codings or Java program. Previously, only Java guys used to do this this Hadoop, right? But now anybody can update with it. So with Scala implementation, or with HQL programming, right? Or with big Latin language.
okay, sir. I have 2 years of experience in Angular, sir. So my experience will be considered at the time of this interview will be scheduled.
So if you're already working in a company, already you worked in a company, right? You can just by the end of this course, right? I'm taking 100 hours, like just go with 45 hours or 50 hours commercial aspects. So, but I'm spending these many hours. I'll be giving nearly 4+ years of much of knowledge I'm going to provide you. So with that experience, you can just add to your resume, and it doesn't mean that if you are good your work with, right? They'll just check if you go for any background check also, they see whether they worked in their company or not, but in which pure network, you can keep your experience in it, Hadoop environment, right?
Okay, sir. Okay.
Fine.
So will
Okay.
you
So
be able to
in deep,
will
so
you be able to take one
so
end-to-end
each and
pipeline, sir?
yes, definitely. At the end of the course, definitely I'll be showing you. And each and everything, each and every class, whatever I discussed, that it will be clear to you. The sessions will be interactive sessions. I want response from your side. That means interactiveness from both the sides, right? All the sessions I'll be keeping you in unmuted status. Any queries there, immediately you'll be asking me. For each and every statement or whatever I do, right, you will be responding with the output. What will be the output for it, right? There's nothing theoretical, everything will be practical. I'll be showing you on this. So at the same time, whatever I perform, right, you will be doing it practically and checking it, right, for your better command on that particular component. The only thing is regularity is required, how regularly you attend, and working with, I'll be giving some assignments, tasks to work with, right, doing those things, and just spending 1 hour for the practicals daily, you can get the full command on this, right? And even for if anyone going for certification program also, I'll just give knowledge on that. Like,
Yes, sir. I have one question about certification, sir. So Databricks certification can I complete after doing this course?
yes, compulsory, right? So Cloudera, CCA 175 certification, or see how that questions, how many number of questions, what is that time limit, the percentage, and how your performance is measured, right? Everything I'll be briefing you. I'll be taking a separate session on that. System requirements, yes. So don't worry about the system requirements. If you've got low system configuration also, I'll be giving multiple things, right? The images to work with your whatever system requirement. So the only thing is, if you've got good RAM capacity, 8 GB RAM like that, your speed will be good. If you've got lesser than that also, if you can extend it, you can extend. Otherwise, with 4 GB RAMs, how we can work on it, I'll be just briefing you, right, in our session.
Will you provide a video or sir?
Yes, everyone, you will be getting every day you'll be getting the recorded session of that video. You can go through that video, you can analyze, and you can ask the queries at the next day at the start of the session itself. If you've got first, I'll going with the queries, and later we'll go with the discussions, right? Yes.
Yeah, I have one question.
Yes.
Here.
Yes.
So we have DURGASOFT is having some other classes on Spark and Scala, right? So whatever they are covering in those classes, the same will be covering in this class, or anything less they will cover in this class, because the curriculum is like there are many topics here, right?
Yes. The thing is, the batch which is going on, I'm only taking it. So it is also a Hadoop and Spark batch only. The Spark has started, Hadoop completed.
Okay.
It's not, there is no specially Spark, right? Hadoop and Spark batches, because you need to have basic knowledge of Hadoop to go with Spark, right? So Hadoop has completed, Spark batch has started now.
So I just want to go for the Spark plus
yes.
So what do you want me to do? Like, shall I?
You asked, right, the same content, whatever I discussed, right, the content is going to be same, right? The same content for all the Spark batches. There is no Spark. If you go with Hadoop and Spark, or only Spark, the same, right? Fine.
Okay. So shall I continue with the same these sessions?
Yes, you can go ahead with this Hadoop and Spark. Or if anybody wants to go parallelly, wants to decrease that time bound, right? So you can go parallelly also. If anybody wants to go, tomorrow I am going with Scala programming, right?
Okay.
Okay, fine. You provide interview questions, sir?
Yeah, definitely. As part of our topics only, I'll be discussing a lot of things, right? What are the queries you will be getting? At the end also, I'll be giving some interview questions, related questions. Nearly some 30 to 40 interview questions I'll be saying at the last on different topics, mostly asked queries. And the roles and responsibilities, what you do, everything I'll be briefing you, and some resumes I'll be forwarding you. You can just do it accordingly. Yeah, everything. Yes, Arnab, everything will be shown from the scratch. That's why I was typing and showing you. I didn't keep any PPT slides, right? Even in the demo session. I can keep all the PPTs, nothing, no PPTs, nothing. Everything I'll be typing and showing you how to open from the scratch. whatever topics, right? And even anything related to the basics also, I'll discuss that and I'll come. That's why I'm saying it's 100 hours, right?
Okay. Thank you, sir.
Fine. Okay.
Will you
So-
show any like live projects which we can like coordinate or correlate the things?
Yes, yes. At the end, I was saying like I'll be showing you the entire flow of a project. Yes. Kafka, yes, Arnav, right? Kafka, I'll be showing you, right? Kafka and Flume Kafka, I'll be just giving you the knowledge on that. I don't know.
What about PySpark, sir?
So see, one thing, Spark is a execution model implemented in languages like Scala, Python, Java, or language. Observe Spark with Scala you can do, Spark with Python you can do, Spark with Java also, Spark with R language also. But Java and R language are very less preferred in the industry. Spark with Scala and Spark with Python both. But Spark, whatever is there, Spark APIs, everything remains same. Only the programming is going to change, right? Spark, how we define variables, how to define functions, collections, everything in Scala and Python. But Spark, whatever the Spark related things remain same. Yes, I am also taking PySpark classes in the weekends as of now. If anybody wants to go with PySpark, Spark with Python implementation, this is for Spark with Scala. Spark by default built by using Scala language. Spark by default written in Scala, right? It's a native language of Spark. Means Scala is only used for Spark environment, no other environment using Scala, right? So that's what total knowledge on Scala I'll be providing you. Then I'll go with Spark, right?
So I was also asking about the PySpark only.
Yes, yes, PySpark. If you want to go for PySpark, right? There are separate batches, right?
Okay, when it is going to start?
Yes, you will be intimated, right? Already one PySpark batches is going at the weekend, right?
Okay.
So I'll let you know, right? If any PySpark batch is going to start, it will be started, right? Within next 2 weeks of time. PySpark.
Okay, okay, yeah, okay. Thank you.
So nowadays everyone is looking for cloud only. What it matters with the will on this how to
See one thing about the resources, everything you forget about it, but how exactly this processing, right? We are going to discuss like Spark processing, Hive processing, Pig processing, right? All this, how the processing, the same thing we are going to use, right? Fine. How this processing is going to happen means I want to get the results in quick time. What are the Spark related APIs? Everything we'll be discussing as what are the built-in transformations, what are the built-in actions you see, that we'll be discussing. Okay, fine. At the end, even if you want, I can show you in that cloud environment also. Fine. So still you people can attend the session tomorrow also at the same time, 7 p.m. with the same link to see more on this, right? How exactly the data storage processing, the other thing is going to happen, right? So if I'm done with your queries, if there are no other queries, then I will just sign off for today. Meet you tomorrow, same time with the same link, right? Thank you all for your time. Thank you.
Sir,
Yes.
sir. Sir, this Redshift and all these new cloud data warehouses, right? They are also based on Hadoop only, right? Meaning they say they need Scala programming and everything.
Yes.
They are on the same lines, right, sir?
Yeah, we have got many things right in cloud side also, but as of here we are going with this syllabus content, right? Those things what are discussed or not covered in this. We will be discussing this, whatever this big data Hadoop courses, that is components and Spark.
Okay.
The built-in.
Sir, are you taking any course on that also, sir? That cloud data warehouses also, meaning they are also distributed databases, right? Are you taking anything on that also, sir?
We didn't get much. We have kept batches on that. We didn't get much response. Everyone preferring for this only, right?
Okay. Okay. Sir, previously to that other question, right? That's what I was about to ask you. Like everybody these days, they talk about cloud data engineering, right? Like they also use this Hadoop and Spark and everything only. So do you think this going towards the cloud, sir? Or
Yeah, towards means after within that also what all these APIs are there, right? What all these Spark related things, what all these Hadoop Hive related things will be going to be the same, right? In that.
yeah, that's
So
right.
how
Yeah.
this processing, you'll be learning that here, right? About
Okay, sir.
about the resource, right?
That's right. Okay, sir. Thank you.
Hi, sir.
Yes.
Last question.
Yeah. Go ahead.
Yes. So basically, for the couple of years, we are seeing that as a data engineers are growing most. So
Mhm.
the path of the data engineer, like when we are completing the courses, then after we are going to be completed the certification in the CCA 175 from the cloud era. Then
Mhm.
after we are applying a job for that, then again we are getting it as a role of data engineer.
Mhm.
Then after how the path is going on, sir?
See, actually today, if you talk like mainly the data engineering work, okay, if you see like extract just like ETL kind of things you are performing, right? Capturing data, storing, querying, storing, sharing the data, right? So acquiring the data, summarizing the data, and so how we are going to pull the data, how we are going to pull, and how we are going to perform based on some applied business logic and processing it, how to process it, and once again you are going to export it to the if the required sources, right? We'll be seeing here this.
So after completing of the data engineers, then we can move forward to the data analyst role.
Yes, compulsory, right? Data analysts, because after this only, right? Even if you talk a typical data scientist need to have the data about that is the information knowledge about this, right? First this is going to happen, next after that you will be applying some ML algorithms and statistical analysis, right, on this data which is processed. Fine. So
Okay.
from this, even in Spark we have got library like Spark ML machine learning library, right? Spark supports this machine learning library. Because of that also Spark has got powerful. There was some other technology like a Flink available which was dominating Spark, but Spark came powerful with this ML machine learning libraries, right? So like the Spark processing, and after that applying some ML techniques, machine learning techniques, and analyzing, right? So typical as of now, the typical data scientist, they are dependent on this data engineers, right? And but in the future, every data scientist need to have the knowledge about this big data, Hadoop and Spark. So even if you go for data science courses, you will see a concept like Hadoop and Spark in that as a part of the course, right? Fine. But
Sir, I
here
have
we,
one question.
yes.
Sir, some
No? Yeah. Any more queries, right?
Could you?
Sir, will you please share?
Share. Pardon?
Hello.
Yes.
Will you please share the PDF of the syllabus, or it is the same on the website?
It is same on the website, right? Whatever is there in the website, the same thing. Again, you'll be getting that to your mail also, right? Tomorrow.
hello, sir.
Yes.
Hello, sir.
Yes. Go ahead.
Sir, some of people are saying data engineering goes down, sir. I have read that statement on LinkedIn, sir. So, what will be your statement on that, sir?
No. Actually, data engineering. No, not like that. Previously, you got Informatica, all those, right? When Hadoop came into the market, you are not seeing that Informatica, that ETL tools. Previously, they have got a great boom, right? ETLs. Now, when Hadoop came, right? So this Hadoop has taken that storing and processing in quick time, right? So if you got any alternative, then you can say that. If you got any alternative, right? For the ETL, right? Extracting, transforming, and loading. But if anything comes into the market, also it should prove in the market. It takes time for that, at least 5 to 10 years. So if any technology comes to the market, immediately, like many POCs will be done on that. So see, Hadoop will be in the market. So you can see, just check in the Google, right? Hadoop and Spark jobs as of now.
Okay, sure.
Sir, is it possible to change the timing of the class? Because in my current project, we have daily Scrum calls from 7:30 to like 8:05 or 8:10. Is it possible? Hello, am I audible?
Yes, but 7 o'clock is the time. So if anybody, right, okay, fine. If unable to attend, you can just go through the video that recording, right? If you've got queries, you can ask me at the next day. You are saying you can, okay. There are many students who are doing jobs just following the videos, but I'm not recommending you that. But anyhow, for at least if you're offering half an hour, you can just go with your queries. But the time changing of time, no. 7 to
Okay, no, thank
7
you.
to 8. Yes.
Good evening, sir. Just wanted to check with you. Like, is there, sir, any upcoming batch which would be morning shift?
No morning shift. No, as of now, there is no morning shift.
So all the classes will be in evening, sir, only.
Evening only. Yes.
Sir,
Okay.
Yes.
sir, only request is, can you please keep the time as 7 p.m., sir? Because we have moved our Scrum and everything for this course, sir. So
Mhm.
can you please keep it at 7 p.m.?
Yes, it will be 7 to 8 only.
Yeah, because sir, because for people outside US, it's like 9:30 a.m. for us. So we have moved all the Scrum to attend this course, sir.
Yes.
So yeah, because from my company, 3-4 people, we are attending it together. So we have moved the Scrum for this course, sir.
Fine. It will be the same timing, right? Yes.
Yeah, thank you, sir.
So, okay. Later, right? Once you get enrolled into the sports, once you get registered, right? Even there will be a group, WhatsApp group for the direct interaction with me, right? Any
Okay.
other questions?
Yeah, we have already registered for the course, sir.
This one
Yeah, we already registered, sir.
means enroll means by paying the fees.
Yeah, sir. Fees also we have sent it, sir.
Okay, fine. Whatever it is, yes. So later we'll be having a group, WhatsApp group for direct interaction, for the technical interactions, other things, right? Fine. So, okay, fine. I'm running out of time. So if you've got any queries, you can go ahead. Tomorrow also you can ask your queries. Tomorrow we'll go at the same time, 7 o'clock with the same link, right? Okay. Thank you all for your time. Thank you. Meet you tomorrow. Fine.
Thanks, Vijay. Thank you all.
Thank you.